So last class we did the multiply and divide. This time we do the add and subtract. Right? Adding and subtracting is usually harder because when you add fractions, you've got to worry about common denominators, and that's not something you've got to worry about when you multiply and divide. So before we add rational expressions, we're going to remind ourselves about how do we add fractions. If they have the same denominator, how do we add fractions? What's the mechanics? You just add the numerators, right? You don't, the denominators stay the same. 1 plus 5, 6, 7. Right? You don't change the 7. I always think of it like 1 apple plus 5 apples equals 6 apples. It doesn't change the thing that you're adding up a number of, right? So this may seem simple, but when we do this with rational expressions, it's supposed to be that simple, and we usually turn it into something more complicated. I mean, this next problem, so many times we get the question, what am I supposed to do? But they already have the same denominator. So just like fractions, right, you just add the numerators. The denominator stays the same. It's no different at all. So if the denominator is 2d plus 1, then you can fill that in. And then you add the numerators. Right? Just add these up. D minus 3 plus D minus 1. How many D's is that? 2. And next 2D, sorry. And minus 4. Negative 3 plus negative 1 minus 4. Right, so if you get them and there's 2 or 3 that are same denominator, right, just add the numerators. Don't turn it into something harder than it's supposed to be. Right? Ready? Okay, but if they don't have the same denominator, when you're adding fractions, you got to find a common denominator. And generally what we want to find is the least common denominator. And by least common denominator, we mean the least common multiple of the denominators 5 and 7. You know, what's the lowest number that both 5 and 7 divide evenly into? 35. In this case, it's really just multiply the two denominators. If you multiply the two denominators, you will always find a common denominator. It may not be the least common denominator, but it will be a common denominator. In this case, it will be the least common denominator. So this is going to be 35. Now, what do I have to multiply this first fraction by so that it has a denominator of 35? 7. So what are you going to multiply by? 7 divided by 7. Right? Because what is 7 divided by 7? It's 1. So really what we're doing is we're multiplying times 1. And we can do that because 1 times anything is the same thing back again. Right? What would I multiply the second one by so that I have a denominator of 35? 5 over 5. So now that everything has the same denominator, add the numerators. Right? This will be 28 plus 10, which is 38 over 35. Now, the simplify part, with fractions, is there any common factors between 38 and 35? No. So, I mean, at the end, if there is something to simplify, you simplify. But sometimes there's not. Good. Okay. Trey, sorry, and Bergen. Okay. So what about in this case? If I would multiply the denominators, would I get the least common denominator? I would get 24. And what is the least common denominator for 4? It would have been 12, right? Now, the process by which we do this with fractions, that's really what we end up having to do with rational expressions. That's why we're going to show this anyways. I mean, most of the time when we're adding fractions like this, if you know your multiplication tables, you just, think about it for a couple seconds. And okay, 12 is the lowest number that both of those divide into. And in order to make this fraction have a denominator of 12, I multiply it by 3 over 3. And I multiply this one by 2 over 2. Right? And I get 9 plus 10 over 12, which is 19 over 12. And once you've determined that 12 is the least common denominator, what would you multiply times 4 to get 12? 3. Right? What do you multiply times 6 to get 12? 2. Good. Natalie, Curtis, everybody, good? Now, how would you have found 12 in like a systematic way so that we can repeat this? To find an LCD, first you factor the denominators. In this case, because it's numbers, what we mean by factor is, break it down to its prime factors. So 4 is 2 squared. 6 is 2 times 3. Now, in the least common denominator will have every factor that you see in either one of these denominators the most times that you see it in either one. So 2 goes in the common denominator. 3 goes in the common denominator. And because 2 is squared in this one, it has to be squared in the common denominator. Right? It's not there 3 times. You don't add 2 plus 1 and make 3. You want it the most times that it occurs in either one. And so that's 2, so that's 2. And now when you multiply 2 squared times 3, you get your 12. I mean, we usually know our multiplication tables well enough for something like this that we just say it because we know the multiplication tables. But when we do with rational expressions, we really do have to go through that process. Good. Natalie. Good. Hunter. Okay, so these are the steps when we add or subtract. And the book kind of deals with them as 2 separate kinds of problems, the adding and the subtracting, but the truth is the procedures are all the same. You got to be a little careful about the subtract, which will show why that is. But in the end, the steps are still exactly the same. Right? First, we'll factor the denominators. Okay, we know what that step will mean. Right? Then we'll determine the LCD, kind of like I just did on the last slide. Then we'll multiply each fraction so that it has the common denominator. And we'll add the numerators. And because sometimes we will have something to simplify at the end, before we start canceling out factors, we need to state the restrictions. Okay. Okay. So first step, what did I say? Factor the denominators, okay? Well, in this case, only one of them really has to be factored, and that is x over x minus 1. And, you know, because I can see that I'm probably going to have to multiply this one by something, I'm leaving some space to the side. Right? Try not to just cram everything together. Plus 2x minus 1 over, and how does that factor? X minus 2 times x minus 1. Okay, so the LCD should have every factor that you see in either denominator the most times you see it. All right, so it should have an x minus 1, and it should have an x minus 2, and there's another x minus 1, but it's still only there once. Right? Remember, you put each factor there the most times it occurs in either fraction. And it's here once, and it's here once, so it's got to be here once. Okay, what do I have to multiply the first fraction by so that it has the common denominator? Yeah, I mean, this is the common denominator. This one's missing the x minus 2. So multiply by x minus 2 over x minus 2. Okay, so now everything has the same denominator, and that is x minus 2 times x minus 1. Now what? Add the numerators, right? I'm going to simplify just a little bit, right? I'm going to say this here is x squared minus 2x. And now I can add it all up, right? That'll be x squared minus 2x plus 2x minus 1, which is x squared minus 1. Okay, what does it say to do next? Restrictions? Okay, what are the restrictions for x? 2 and 1. X does not equal 2, and x does not equal 1. Does not equal. Okay, what does it say next? Simplify. And at this step, it's not always that there's something to simplify. But when you see x squared minus 1, I think you should be able to forecast a little bit. Is this going to be worth it to simplify this? I mean, how will x squared minus 1 factor? X minus 1, x plus 1. So you're going to be able to simplify by canceling the x minus 1. So there is something to do here. So we need to simplify by writing this like x plus 1 times x minus 1 divided by x plus 2, x minus 2, sorry, divided by x minus 1. And now you can cancel the x minus 1s. So equals x plus 1 divided by x minus 2. That's the answer. And the answer really should be accompanied by the restrictions. What you got? Trey, you all right? Okay. Anybody? Shan? So you try that one. Here's the steps. Right, this will be one of your you tries. Goes on a piece of paper. I already had that. That one you had to multiply by. I'm not sure what you did. Oh, this is the first fraction. That's this one.
Yeah. Yeah, but that's after I added the numerators.
Okay. Not sure where that 2 comes from.
Yeah,
How did you factor that one denominator? It's a difference of squares, right? What was the LCD? Yeah. I mean, without writing it somewhere else, you probably just comparing these two say, okay, what do I have to multiply this by so that it has this denominator? And what do you say? The x minus 2, right? This one's missing the x minus 2 that this one has. Let's see. What did you multiply by x plus 2? You already got an x plus 2. Should be x minus 2, right? And then that's 1 times this stuff. It's not like 1 plus. It's 1 times parentheses x plus x minus 2. So you do all that, and then you got everything there. You should have been x plus x minus 2. It's like you multiplied this times this, but it's actually, there's a plus in between. You're adding these. Oh, okay. Right? You stuck? Stuck? Who's not stuck? Lee? Let me see this. Questionable. Yeah, what do you think that you get? X minus 2. Okay. I'm just trying to remember. Yeah, what are going to be the restrictions on that? X does not equal 2 or 2, right? So that part is x does not equal 2 or negative 2. Okay, then you got to add the numerators. X plus x minus 2, which is 2x minus 2. Okay, so we've done all this. We've stated the restrictions. Is there anything to simplify here? I mean, could you factor out a 2 and make it 2 times x minus 1? But would you be able to cancel anything if you did? No. So, I mean, if you just, usually polynomials in the numerator are just left in standard form, no parentheses or anything. Denominator is usually left in the factored form like that. So that's a good place to stop right there. Okay. Do we see how that worked? So if you could only do one more, you'd get it right. Right? Do that one. Try again. What kind of factoring are you going to do in that one denominator? GCF. What's the greatest common factor between x squared and x? X. Okay. you have to factor that denominator. Right? Greatest common, what's the greatest common factor between x squared and x? So factor out an x. Maybe we have to rewrite it. No. If you factor out an x, it would be x parentheses minus 1. Come on. There. That's it. Done. Finish. Okay, that's this factor. So now you gotta do your common denominator and all that. Yeah. Let me see. Where did you factor this denominator? Factor. It's like the first step. How could you forget the first step? Right? First step. X plus 1, x minus 1 plus negative 2 over x times x minus 1. Right? Everybody should have had that denominator factored like that. Then what are you going to multiply by? X. X. Yeah, I mean, what's this denominator missing that the common denominator is going to have? It doesn't have an x, right? The both x minus 1 is in both of them. So you need to multiply this one by red x. So now they're the same denominator. Add the numerators. You get it? Where's that? Okay, but now you got to add. No, what happened to the? Did you multiply this, the first one, by x? You get it? Multiply x squared plus x minus 2, which is x plus 2, x minus 1. The minus 1's cancelled. Boom. Boom. Super. What kind of a mess is that? Can't you factor the numerator? Are you drawing on my desk again? I don't believe it. Who's got it? You think you do? What does that say? 2x squared? Yeah. No. When you do this here, it should be x squared plus x minus 2. You're on the way. All right, now just put all that into one numerator. Let's see how you did that. So x squared plus x, what were you going to write? It'll be x squared plus x minus 2. When you put it all together, and now it's over. Right, but then this, you can factor. X squared plus x minus 2. And I think that's right. Maybe not quite. Let's see. Okay, so once you've multiplied this one by the x, then it should have looked like this. X squared plus x minus 2 over x times x minus 1. So does it look like we could factor the numerator, and would it help us to factor the numerator? It does, right? Because how would the numerator factor? X minus 1 times x plus 2, and since there's an x minus 1 in the denominator, this is going to help. All right, so before we start doing that, state the restrictions. X does not equal 0. Remember, if it's just an x by itself, then 0 is the 0 and 1. So x does not equal 0 and 1. And now, with that numerator, we're going to say x plus 2 times x minus 1 divided by x times x minus 1. And of course, now you can cancel a common factor, numerator and denominator. And what's left? X plus 2 over x, comma, domain. Okay. Almost? All right, almost. That's why you get homework, right? It's like John Wooden said, right? I told you the John Wooden quote. Who's John Wooden? Oh my gosh, you guys are so young. He was the coach of the UCLA basketball team in the 60s. They won like 10 NCAA championships in a row. Probably considered, if not the best sports coach ever in America, right up there in the top 2 or 3. He said all learning could be broken down into these steps: explanation, demonstration, imitation, repetition. So I explain a concept, I give you some examples, then you try to imitate it, right? The first time you do it, you're just imitating. You may not understand exactly what you're doing or why you're doing it, but it's like trying to imagine he was a guy trying to teach basketball players how to do certain things. And he was particularly famous for working with big guys who footwork is like really important. They don't just stand around in the middle and grab rebounds. You know, how you block people out and all that is important. So you're trying to tell somebody against their better instincts what they should be doing, and just imagine the big basketball player watching him and trying to imitate it. It's not in his, instinct to do it or in his muscle memory, but then he imitates it and then he repeats it. He practices it. So, at this point, we're at the point of imitation right now. Go home and try some homework. Do a little repetition of it. See whether, doing it a few more times will make it come more clear. Okay, so that takes us from the addition to the subtraction. And like I say, there's really not any difference. All these steps are the same. The only difference here is that because of the minus, which is in front of that fraction, you have to take into account that that is going to make the signs of both of those in the numerator negative or opposite. Whatever they are, this thing flips the sign of everything that follows in the numerator. And that's a place where you'll make a mistake. Right? So besides that, we're going to start the same way, factor the denominators. This is not a you try, this is a me try. Right? This is the demonstrate part. How does the first denominator factor? X times x minus 2. Okay? Let me go over here. Minus. I'm leaving space in case I have to multiply. How about the second fraction? 2 times x minus 2. So the LCD should have every factor that we see. X times x minus 2. And then you jump to the next fraction, and there's a 2 that we didn't already have, so we need to put that in there. And there's another x minus 2, but we've already got an x minus 2, so we don't put another one in there. So the least common denominator is going to be 2x times x minus 2. Okay, what do I have to multiply the first fraction by so that it has that common denominator? 2, right? So this will be 2 divided by 2. Right? What do I have to multiply the second one by so that it has this denominator? X. Right? So this will be x over x. Now, both of these have the same denominator, right? so we can add or subtract the numerators. Oh, or I'm at blue. So before I do that, I'm going to go like this. I'm going to say 2x plus 2 is 2x plus 4. And then it'll be minus x squared plus 2x. Right? I'm just distributing what I've got before I start subtracting. And now, let's simplify. Putting it in order, highest degree term first, right? It'll be negative x squared. How many x's will there be? 2x minus 2x. 0. 2x minus 2x. None. And then the constant term will be 4. Plus 4. What's that?
Like, don't you have to, like, make it so the x is
We're not done yet. You're not done yet. So, okay. Now at this point, if you're looking ahead, does it look like we're going to be able, if we simplified, there would be something to cancel here? I mean, you should be looking at this negative x squared plus 4 and thinking, you know, if I factored out the negative, like Curtis just said, I would have negative x squared minus 4. Difference of squares, x plus 2 times x minus 2. And you got an x minus 2. So definitely you want to go ahead and make that step. But before we do that, what are the restrictions? 0, 2. Remember, when you have an x, the standalone x is not plus or minus something, then 0 is the 0. So we're just going to say here, x does not equal 0 and 2. Okay, and then I'm going to write it, take me a couple steps here. Negative x squared minus 4 over 2x times x minus 2. Right? All I've done is factor that negative in front of parentheses. And then it'll be negative x plus 2 times x minus 2 over 2x times x minus 2. Okay, now cancel common factors. So this thing simplifies as negative x plus 2 divided by 2x. Or you could distribute the negative, call it negative x minus 2. That's fine. Now, what if you got all the way down to this part right here and you didn't simplify? It's a little wrong, right? It's not a lot wrong. If you did everything else right up to that point and you just didn't see that last step of simplify, you know, the way I grade, when I'm grading them, you know, I always think out of 5 points, that's a minus 1. You know, that's a very little mistake compared with everything else you had to get right to get to that point. Honestly, I don't see most of these problems where actually it is simplifiable at the end, but there is some. Am I okay to do that? Oh, sorry. Okay, then once we had the same denominator, then we're supposed to combine the numerators, right? So here I multiplied 2x plus 4 to get that. I multiplied x squared plus 2x, that's that. And then I'm subtracting, right? The negative x squared comes from negative x squared. The 4 comes from there. And this 2x cancels with that 2x because there's a subtract in between, right? Does that answer it? Good? Everybody good? So try that one. How'd we do factor in that denominator?
X plus 5,
X plus 5, X plus 1. Okay, you didn't have it, now you do. So you started with that, you factored to get that, and then you said this one was missing. What was it missing? No, it's plus 1. Okay, so now you're going to have to multiply that. Okay. So, and then this, x minus 1 times x plus 1, that's a 4. How are we doing? Okay, so what's this one missing? Right, say x plus 1 over x plus 1. Doing all right? What's x plus 1 times x minus 1? That's a factoring of the difference of squares. What's the difference of squares? Which difference of squares factors is x plus 1 times x minus 1? X squared minus 1. Did you get it? So, factors of -4 that add up to -1. Are there any? Then you're done. So we all got to this point, right? Stuck. My, oh my. X minus 1 over x plus 5. And now leave some space. X plus 3 over x plus 5 times x plus 1. So what do I have to multiply to have the same denominator? X plus 1, right? So I'm going to do that. Blue, no, red. X plus 1 over x plus 1. Okay, now x, what is x minus 1 times x plus 1? X squared minus 1, that's the factoring of a difference of squares, right? We should recognize that and just go straight away to X squared minus 1. I mean, if you don't, you could FOIL it, but that's what you're going to get. Okay, and then the minus X plus 3, which is going to be like minus X minus 3, right? The negative will distribute on both. So the denominator is X plus 5 times X plus 1. And what's in the numerator? X squared minus X minus 4. Okay, state the restrictions. X does not equal negative 5. X does not equal negative 1. Okay, now is there some simplifying for us to do here? I mean, when you're looking at something like that, you got to just ask yourself, are there factors of negative 4 that add up to negative 1? Really? What are they? No, there's not. It's not factorable. It's not factorable. So you're done. At that point, you're done because this can't be factored anyway, so just stop. I think that's much more the common case, is that there is nothing to do when you get to that step. This new edition of the book has got a lot of examples in there where actually you get to the end and there is a little bit more to do. Okay, so that's the adding and subtracting. One more thing that we got to do, especially for Lee, because he needs a challenge, right? Huh? What? You paying attention? Okay. All right, the last thing is complex fractions. Complex fractions means, okay, hurry up. Complex fractions means fractions inside of fractions. Right, these are 3 examples of complex fractions. One, a lot more complex than the other, right? But you could see in the numerator, there's fractions. In the denominator, there's a fraction. Same thing here. Here we've got the sum of rational expressions and the difference of rational expressions. That's what we mean by complex fractions. And we can simplify them, and it involves adding and subtracting and finding least common denominators and all the things we did in this lesson. Okay. You don't need to copy every little thing, maybe just that part right there. They just copied from the book, right? You already have this. Right? And we're going to simplify. Simplify means just turn it into a rational expression that does not have fractions inside of fractions. And we have 2 ways of doing this, right? There are going to be 2 methods. The first method is look at the denominators for all what I would call the inner fractions, right? This is one big fraction, but inside of it, there's 1, 2, 3 fractions, right? Find the LCD for all of those. Okay, well, X, Y, Y. What's the LCD? Yeah, but what is it in this case? If the denominators you're looking at are X and Y and Y, X, Y. Right? Remember, you find the LCD. You find the LCD by writing down every factor you see the most times you see it. There's 1 X there, there's 1 Y there, and there's 1 Y there. So X, Y. Okay. Once you know what that least common denominator is, then you multiply the numerator and the denominator by that. So it'll look like this. XY divided by XY. Which again, that's 1. You're allowed to do that. Now, distribute. Simplify. Do what you have to do. In this case, it's a distribute. right? This will be like this and like this and this. So the first one will be xy over x. The second one will be x squared y over y. And the denominator will be xy over y. And then here it'll be xy.
So, what exactly, like, I'm confused. Like,
Do you know how we found the least common denominator?
yeah.
Okay. Do you see where I multiplied by that least common denominator?
Oh, yeah.
Okay. Now, we're not done yet. We're not done yet. Now, notice in each one of these terms, you can cancel the denominator. Because you multiplied by the least common denominator, that means all the denominators will divide into it. So in this case, the x cancels with x. The y cancels with y. The y cancels with y. And done. And you write your answer. Right? The answer is y plus x squared divided by x plus xy. Done. So now we have a rational expression, but there's no more fractions inside of it. Right? So, yes. The least common denominator has every factor you see the most times that you see it. So this denominator has an x one time. This denominator has a y one time. That's why there's an x and a y. This one's got another y, but we've already got a y. That's it. Okay, the second method, oh wait, for everybody to be done. Good? Good. Good. Okay. The second method is, do what we did to add these expressions. Just in the numerator, find the least common denominator, add those two. In the denominator, find the least common denominator, add those two. Right? That's the first step. And then divide. How is it that we're going to divide a fraction by a fraction? You flip and multiply. Right? So first, let's find the least common denominator just for the numerator. What is the least common denominator for the numerator? X times y, right? So multiply this one by xy. No, I'm sorry, that's wrong. Edit, undo. Edit, undo. So we're gonna multiply this by y over y, and this by x over x. Okay, what's the least common denominator in the denominator? Y. So multiply this 1 times y over y. Okay, now you can add, in the numerator you've got y plus x squared divided by xy. In the denominator you've got 1 plus y divided by y. And then now we're dividing a fraction by a fraction, so we turn that into a multiplication by flipping. Right? Y plus x squared over xy times y divided by 1 plus y. And then let's see, any canceling we can do? How about this y cancels with this y? What does that leave us? Y plus x squared times x times y, 1 plus y, which is x plus xy. Same thing. We're good? Okay. Now, we're going to do this one right here. Which thing would be easier? Which one do you like the most? Would you rather do the one where we find the least common denominator for both of them, for all of it, like we did? Or the second one? The first method? Okay. When you're doing them, you could do whatever you want. Okay. Okay. So remember, the first method was find the LCD for everything, which in this case is kind of, what is the LCD? XY, right? There's only these two fractions. Their denominators are x and y, so the LCD is xy. So what do I do with that according to the first method? I multiply the top and the bottom by xy. Okay, so that'll be x squared y divided by xy over x plus xy over y. Which is x's cancel, y's cancel. Here? No, why not? Is y a factor of the denominator? No. Factors multiply. Is y multiplying times the rest of the denominator? No, you can't cancel it. That's what I told you on the first day of this stuff. You can't cherry pick a term and cancel it with something on the other side. When you make that kind of mistake, I'm taking off probably 4 out of 5. That is a bad mistake that you shouldn't be making. There's not much you can do to recover it. You start doing things like y cancels y or x cancels x. These two are not factors, they're terms. They're not multiplying times everything else in the numerator or denominator. I meant these to be you tries, but we're running out of time, which is not normal. Usually we don't go this long. But this is the hardest lesson in the hardest chapter, in my opinion. Yeah, for the year. For the year. This is probably the hardest lesson of the hardest chapter. It doesn't mean it's the hardest lesson, but it's probably, out of this chapter, it's the one that causes us the most trouble, and the chapter is the hardest chapter, for sure. So I think what I'm going to do is I will add this myself later, so don't worry about this one, okay? Did you finish? Everybody finish with that? Okay. I'll add that to the video and to the notes if you want to look at it. The homework is going to be this page, quiz next class over 8.2, 8.3, and 8.4. Go back and look at what we did for those. Okay, one more example since we didn't get to it in class. It's another simplify a complex fraction. And since I did the first one using method 1, or the last one, then we're going to use method 2. So let me get rid of this, edit, cut, and shrink this up a little bit. And okay, so for the numerator, the least common denominator will be x times x plus 1. So I will multiply the first fraction by x plus 1, over x plus 1. And I'll multiply the second fraction by x over x. And when I add that up, I'm going to get x squared plus x, minus x minus 2 plus the 2x. So what do we get all together? We have x squared plus x minus 2 divided by x times x plus 1. Okay, in the denominator, the common denominator should be x minus 1 times x plus 1. So let's multiply this by x plus 1 over x plus 1. Sorry if that's hard to read.
All afternoon activities are canceled due to the water being off in the building. Please make sure you board the buses. Thank you.
Okay, so we're just finding common denominators individually for the numerator and the denominator. And when I add these together, it's going to be a big fraction bar here, a double. This will be 3x plus 3 minus x plus 1. So the 3x minus x will be 2x. The 3 minus a negative 1 will be 3 plus 1, or 4. And the denominator is x plus 1 times x minus 1. Okay, then that's the first step. Find the LCDs, add. And now I'm going to turn this division problem into a multiplication problem by flipping the second fraction. And I think at the same time I'm going to factor this. I'm going to factor the numerators. Now I'll take another step. So this will be x squared plus x minus 2 divided by x times x plus 1 times x plus 1 times x minus 1 divided by 2x plus 4. And in fact, I can factor a little more here. I mean, this numerator here would have been x plus 2 times x minus 1 divided by x times x plus 1 times x plus 1 times x minus 1 divided by 2 times x plus 2. And now I can get all the canceling that I can done, right? This x plus 2 cancels this x plus 2. This x plus 1 cancels this x plus 1. And what is left? Looks like we've got an x minus 1 squared and a 2x.